Greetings, mathematicians. We have example 5, the OR special cases, solving graph profiling OR statements. So we have this inequality right here, and we're going to go ahead and solve both just like we normally would. So we have negative 3x plus 5 is less than 8, or negative x is greater than negative 4. I'm going to go ahead and isolate the variable, so we could just go ahead and solve. So we subtract 5 from both sides. Those cancel. Negative 3x is less than 3. And then we just go ahead and divide by that negative 3. Okay. So I'm dividing by that negative number. I'm going to go ahead and write my answer over here. So we have x. I have to flip this inequality, so it's greater than. And then 3 divided by negative 3 is negative 1. Okay. And then this is an OR statement, so we're going to go ahead and pencil in that OR. Okay. And then we have to go ahead and solve this inequality right here. So negative 1 times x, right? So the inverse of that is just divide. So I'm dividing both sides by negative 1. Okay, so we have x, and then I have to flip this inequality. So this becomes less than. Negative 4 divided by negative 1 is 4. Okay, so let's go ahead and pencil that in over here. So we have x is less than 4. So at first glance, this looks like a totally okay answer, but let's think about numerically what is going on. So we have x is greater than negative 1, or x is less than 4, right? So let's see what happens if we would graph that. I'm going to put negative 1 right here, positive 4 over here, right? So x is greater than negative 1, right? So let's see what happens there. It's going to be an open circle, and it goes in this direction like that. Okay, so going to the right. X is less than 4, so again, that's going to be an open circle, but it's going to the left, right? If you notice, the negative 1, it's going to the right forever, right? It's going all the way to the right. And then same thing with that 4, we're going to the left, right? So we're going in this direction here, and it actually continues forever in all those directions. So if you notice, I actually went ahead and I highlighted all the possible numbers on this number line, right? So our answer is actually all real numbers. So I can do this double bar R, all real numbers, right? No matter what number I select, it's going to be true for that inequality. Okay, let's go ahead and take a look at that next example. So we have 5x minus 3 is greater than 6, or 7 is greater than 4x minus 9. Okay, let's go ahead and solve. So add 3. Cancel. 5x is greater than 9, okay? And then we just go ahead and divide by 5. Okay? So our first part, we get x is greater than 9/5. It's a fraction, but that's okay. Okay? And then we're going to go ahead and write that OR. And then we have to go ahead and solve that second part of that inequality. So we're going to go ahead and add 9 here and here. Those cancel out. 7 plus 9 gets me 16, greater than 4x. Okay, and then we just go ahead and divide by 4. 16 divided by 4 is 4, is greater than x. And I'm going to rewrite that so it looks a little bit nicer. This first inequality looks fine, so we have x is greater than 9/5. Or x is less than 4. Okay. Again, at first glance that looks good, but let's think about what is happening numerically. I'm going to go ahead and put these on the number lines. We have 9/5. That is approximately 1.8. It is equal to 1.8. And then here we have 4. So we want all the numbers that are greater than 9/5. So it's an open circle heading to the right forever. And then same thing here, we have x is less than 4, so technically it would be an open circle there, and it's heading to the left forever. Okay? Same thing as the one previously. That is the whole number line, meaning that our solution is all real numbers.